Okay, today we're going to talk about capital budgeting, specifically learning more about the net present value. We covered the terminology and definitions of book value, market value, yield, and net present value, and even made the statement that if you truly understand those terms, you can do a lot in the world of investment if you truly understand it. And thus we've spent a lot of time trying to build up, and we're going to spend a lot of time today trying to help reinforce your understanding of these concepts. We presented in the context of a single period model, something that's intuitively obvious to each of you as it relates to these terms and definitions. And then we broaden it using bonds into a multi-period framework. And although it's a little more rigorous, hopefully you can draw upon the intuition from the single period model to understand what we're doing, and hopefully that helps today as well. Today's lecture, we're going to talk about capital budgeting. We have spent a good chunk of this course already developing the time value of money formulas and factors, and hopefully you have an understanding of what we're doing by moving cash flows from one period to the other. Now we're moving out of the time value of money into the area of investments or capital budgeting, how to allocate our resources, our wealth, so that we can optimize our earnings or our profitability. So we're going to use the time value of money now in the area of capital budgeting. We're going to first today talk about decision criteria and rules. Then we're going to show how net present value can be used if we use net cash flows. We're going to get into the net present value using the component method. We'll argue that there's a reason for using the component method as opposed to the net cash flows. In terms of the reading assignment, you're now into Chapter 10. Okay, the decision criteria, one we can use is the net present value. Second is the internal rate of return, and we spent some time defining each of those. Another method that is used in business is called the payback method. It's a very simple concept. If a firm invest $10,000 and that firm or that investment returns $2,000 per year, then it's going to take 5 years to return the capital invested. It's a simple method, but in most cases it ignores the time value of money. Some cases they try to include the time value of money, but when they start doing that, then it goes back in, well, why not use the net present value in the first place? Another one is the simple rate of return, and that's used simply because it's simple, but it ignores the time value of money, so it's not as powerful. The bottom line is the net present value and the internal rate of return are the more theoretically correct procedures to use, so that's what we're going to focus on in this class. However, the textbook does cover payback method and the simple rate of return. You should read that so you're at least familiar with it by definition, because when you interview, there are firms out there that still use the payback and the simple rate of return. Okay, looking at the net present value, we're going to focus on the cash flow method of calculating the net present value. And if you look at this, you see that the present value of the cash inflows is captured in what I've circled in red. And the present value of the cash outflows is circled in green. If we look at this cash outflow, which we represent as this C0 representing the cash flow today, is the initial cost of investment, which is also what it cost us, which is the present value of cash outflows. If we look at cash inflows, notice that we have the cash flow at time n. And we're going to discount that at the required discount rate for n periods. And we're going to do that for every period, starting with the first period all the way to this big N, where the big N represents the maturity of the investment. So if we have an investment that's going to have payoff for 10 years, then that big N would be 10. And then, of course, where this cash flow has a big N, that represents the terminal value of the investment. In other words, at the ending period, when we're done with that investment, we have a salvage value or a terminal value or a teardown cost or disposal fee. All of that comes at the end of the investment. If we look at the rule for profitability, in other words, if we choose the net present value as our decision criterion, then what is the rule to claim whether this investment is profitable or not profitable? It turns out if the net present value is greater than or equal to 0, then we say it's profitable, it's acceptable. If the net present value is less than 0, then it's unacceptable, and we would reject it. To help understand whether you truly understand what's going on here, so let me ask a question. If the net present value of an investment is equal to 0, then that implies that you have a 0 rate of return, true or false. So it's not 0, is it? You can also make another statement. That the profit is equal to the required rate of return, which is what we've established, but there's a word for it. The required rate of return at that point, where net present value is equal to 0, is called the yield. If the net present value is equal to 0, that rate is the yield, but it's also what was said initially, is that it's the required rate of return. You get exactly the required rate of return. So now let's broaden that. If the net present value is equal to 0, then the required rate of return is also equal to the yield. Or let's say that your required rate of return was equal to 10%. Sometimes this is too abstract, so let's put some numbers to it. If you require 10% on your investment and you do the arithmetic and the net present value comes out to exactly 0, then what is your rate of return on that investment? 10%. Okay, so back to that statement when I said if the net present value is equal to 0, is the rate of return equal to 0? The answer is emphatically false. But you're getting exactly your required rate of return. So if the net present value is greater than 0, what can you say about the rate of return or yield on that investment? You're getting more than the required rate, or something more than 10%. On the other hand, if net present value is less than 0, what can you say relative to 10%? Yeah, the yield is something less than 10%, and why would you invest in something at 8% when you can get 10% somewhere else? Okay, now let's turn to the internal rate of return, or the IRR, or the yield. To calculate that, we set the net present value equal to 0 and solve for the R. Now, something that hopefully becomes abundantly clear in this lecture today is that the net present value and the yield come from the same equation. They come from the same timeline. You're using the same keystrokes. The difference is, if you calculate the net present value, you know the R, you know the discount rate. If you're solving for the yield, you set the net present value to 0 and you solve for the R. One equation, one unknown. You're just solving for a different unknown. You know, the net present value is real basic. If you understand that the yield is the same thing, you're just setting the net present value to 0 and solving for the R. Now, solving for the R is not always easy, but conceptually, it's easy to know what you're solving for. So this provides the yield or rate of return on the investment. The rule is, in profitability, if your IRR or yield is greater than what you require or equal to, then it's acceptable. If you require 10% and the yield is 10% or greater, you're okay with that. However, if you can get 10% on your investment, this investment you're looking at is something less than that, then you reject it or it's unacceptable. It's not terribly hard to understand. If you go to Compass Bank and you can get 4% on CDs, and then you go evaluate in town other alternatives of where to put your money for CDs, and Texas Aggie Credit Union's only paying 3.5%, what are you going to do? You're going to go back to Compass Bank, or you're certainly not going to go to the Aggie Credit Union, right? I mean, if you got investments out there that'll pay you a certain amount, you're not going to accept anything less than that. Now, let's take this concept of the net present value and the internal rate of return and apply it to a problem. Now, since this is an agricultural class, the problem that I'm going to use is not a widget. I'm going to use a mechanical post hole digger. There is a mechanical post hole digger. Connects to the back of a tractor, connects to the PTO of the tractor, and it drills a post hole, as opposed to the post hole diggers by hand. This is the price on it, although my price that I'm going to use is a little different, but this visually helps. You know, the post hole digger is nice. And I can tell you, though, that my father, while I was on the farm, never purchased one of these mechanical post hole diggers. Why do you think he chose not to? He had free labor. No, his net present value for purchasing that was actually less than zero. Why? Because he had no return. He had free labor, which may explain why some of your parents never bought one of these. But in this particular case, we're assuming that this farmer, his children are now at A&M, and he has to purchase the labor from high school students. So we're assuming that he's got a discount from his local dealership and he can get it for $300. And it's projected that he needs to hire high school students that cost him $100 a year that he pays at the end of the year to dig those post holes. We're assuming that this post hole digger is going to last for 4 years, and at that point it has no value. We're making these big assumptions. We're also assuming that this particular farmer can invest his money at 10%. So to determine whether if this is a good investment or if this is a good capital purchase, we're going to calculate the net present value. And the first thing that you do, and I strongly encourage this, and any time you start working with a investment, lay it out in a timeline. So we draw our line. At time 0, we're saying that it's going to cost us $300. It's going to cost this farm $300 to purchase this digger. And we've also said that we're going to save $100 at the end of each of the next 4 years, at which point then the digger has no value. Now this is something that you need to get used to in the problems. Nobody's giving this farmer $100. It's not $100 coming into the business, but we can consider it a positive cash inflow because if we didn't have the post hole digger, we'd have to pay somebody else $100 that we now get to keep. So you got to get your minds around that concept, because you're going to get in the wording of the problems, the homework, and in real life, you sometimes have to think of savings as a positive cash inflow. The rate was 10%. And what we want to know is the net present value. And what's the definition of net present value? The present value of the cash inflows minus the present value of the cash outflows. The outflows are in green, the inflows in red. And you'll notice that the inflows, conveniently in this particular problem, are a series of payments and they are uniform. That means that we can then calculate the present value of those savings using the USPV factor at 10% for 4 periods. Now, if we took this problem and we plug that into our calculators at 4N, 10% I, $100 payment, zero out the future value, and compute present value, we would get $316.99. That's our present value of our cash inflows. We subtract out the present value of the cash outflows, and we do the arithmetic, and it comes out to $16.99. By rule, since it's a positive amount, then we say, okay, it's a good investment. Now, if I ask you, what's the rate of return on this investment, what would you say? You can say that because the net present value is positive, that the rate of return is something greater than the required rate of return. The required rate of return was 10% given in the problem. Then you can say the rate of return is something greater than 10%. We know it's something greater than 10%, but how much? Don't you want to know what your rate of return is? Well, we calculate the yield, the internal rate of return. Notice that our timeline looks the same as it did before, except in this case, we're going to set the net present value equal to 0 and solve for what? We're going to solve for R. If you compare the previous slide with this slide, notice that the net present value equation is the same, except in this case, the R is unknown and the net present value is unknown. You got two unknowns with one equation. Can you solve that? No. But by definition, we said we're going to find the rate that makes the present value of the cash inflows equal to the present value of the cash outflows. If the quantity, which is the present value of cash inflows, is equal to the present value of cash outflows, what does that imply about the net present value? It'd be equal to 0. So if the present value of cash inflow is equal to the present value of the cash outflow, it implies then that the net present value is equal to 0. And once we set net present value equal to 0, we have one equation with one unknown, and then we can solve for it. Okay, now it turns out that in this problem, as I'll show you, we can use our calculator to solve for it. These type of problems can't be solved directly. It requires a search procedure. Even for your calculators, even for Excel, it goes through a search procedure. And right now, we're going to show you how to solve for a problem such as this, where you can't solve the problem directly. Now, I want you to look at your previous slide where you have net present value equal to that equation with the unknown r. And to solve this search procedure, we're going to grab a number out there. Doesn't make any difference which one. You just grab a number. Now, there's some reasons to use some over the others to simplify the process, but we need a starting point. So I'm going to grab 10%. I'm going to take this rate 10% and plug it into the equation that's on your previous slide. And I do so, and I get the net present value of $16.99. As it turns out, that 10% is too low. So let's grab another number that's a little bit higher. Any number. Let's try, let's say 14%. Plug 14% into that equation on the previous slide, and notice that the net present value is negative. So 14% is too high. So let's try a number that is a little more than 10%, but less than 14%, because we can see that the answer is bounded somewhere between 10% and 14%, because the net present value for one is positive and it's negative for the other. Let's try 11%. We plug it into our calculators. You can test me on this to make sure I'm doing it right. Plug it into the equation. I come up with a net present value of $10.24, which makes it that 11% still too low, so let's try 13%. Well, it's still negative, so let's try something a little lower. Let's try 12%. We can say it's somewhere between 12% and 13%. Now, if we look at this graphically, on 2 slides back, we had the equation for net present value, which we have on the vertical axis, as a function of the discount rate R, which I have on the horizontal axis. Remember that when we plug 10% into that equation, the answer came out to be something like 16.99%. And then we plugged in 14%, and it was around a -8. These points you see that they're on the line come from that equation, the net present value equation, for different rates. And we can plot the line. If I gave you any equation, any one equation with 2 unknowns, you could plot a 2-dimensional graph, right? I'm pointing out, however, as your calculator is going through this same search procedure. In fact, as you get more complicated problems, when you push I, you'll see it go like this. Why? It's because it's searching. I expect you to be able to do that as well. Instead of just watching your calculator blink and say, oh, that's odd, I want you to see that it's actually going through a procedure. The same bounding procedure is what we just did. And I'm showing you graphically so you can see this relationship between the net present value and the yield, because what is the internal rate of return, or the yield? It's when that net present value crosses the horizontal axis. That's what the yield is. There's a relationship between the yield and the net present value. Okay, as I mentioned in this particular problem, we can actually use our calculator. We lay out the problem where you have the outflows, you have the inflows, and we set net present value equal to 0, and we solve for the R. Here's the equation again. I've put the equation up. We have the net present value as a function of this R. We set the net present value equal to 0. We can add $300 to both sides. And then what do we have here? This $300 is the present value. This $100 is a uniform series. We have a present value of a uniform series. We can now use our financial calculator that has the factors embedded in them. Notice that we have 4N. We have a $300 present value. We have a $100 payment. Zero out the future value. Calculate the I, compute the I, and it comes out to 12.59%. It turns out that some of the problems that you'll face is not going to work on the 5 financial functions that you have. Your problems may be too complex. This one was very easy because it had one uniform series. When you get to your investment proposals and it's expected that you calculate the yield, you may have 360 or more periods with uneven cash flows throughout it. And if you try and calculate the internal rate of return by hand, I can tell you you're going to spend an evening or more doing it. And there's no reason for it because all of you have access to Excel. And Excel, the formula is very easy. To find the internal rate of return, you basically identify its timeline, which we refer to as values. And notice that even the internal rate of return, the almighty computer, has to have a starting point on a search procedure, so you give it one. That guess is just that. You pull a number out of the air, put a 0.1 or a 0.5 or a 0.01, and you stick it in there so it has a point of reference. Now, if we look at the Excel spreadsheet where we're trying to solve for it, we put in the cell, which I circled in red, you put an equal IRR, and notice that A1 represents the starting point times 0. Then you put a colon, and then you reference the ending timeline, and it recognizes each of those as incremental of one period. So it's E1, and then you put a comma, and notice I put a guess in of 10%, 0.10. Could have been 0.05, it could have been 0.3, whatever you want to put in there, you put in that guess, and notice that it gives you the right answer. So just as a heads up, when you start doing your investment proposal or you start doing project for your real world, the IRR can be very difficult to calculate through the search procedure. Okay, in this particular case, the internal rate of return or yield was 12.59, which was greater than 10%. Therefore, the investment is acceptable.